Question 17. An array was originally 4, 5, 10, 7, 7. After one pass of the sort, the array became 4, 5, 7, 7, 10. Which of the following are all the sorting methods listed capable of producing this result? So I've got the usual suspects: bubble, insertion, selection. Now we have a bit of a look at these. The insertion is in those three. So maybe if we can eliminate that, we'll be left with the correct answer. So I'm going to start with insertion sort and do one pass sort. So we begin with 4, 5, 10, 7, 7. Insertion sort, you start by thinking about that we have a sorted list here. It's a very small sorted list with just a 4 in it. That's already been sorted. Then we look to the next element, which is the 5, and see if we need to move it or not. That's one pass of the insertion sort. Now obviously 4 is smaller than 5, so we don't actually need to move it. So our now sorted list after one pass includes 4, 5, and 10, 7, 7. So one pass of insertion sort doesn't actually change it. Now we could have done it from the other way, where we considered this the sorted array. So after one pass we look at the next element and move it if we need to. But because they're both 7, then they stay as they are. So either way, we start from the front here, or we start from the back. Either way, after one pass of the insertion sort, we're not going to have 4, 5, 7, 7, 10. So we can eliminate all the options that have insertion sort. Now that's just lucky. In this case, that we're left with the correct answer of B. But let's have a look at the other options anyway. So what would happen with the selection sort? Now selection sort, you look from the start to the finish and you try to find the smallest item, and then you just make sure that's moved to the front. So we look at the 4, then the 5, then the 10, then the 7, and the 7. Well, 4 is obviously the smallest, and it's already at the first position. So there'll be no change with the selection sort. But, again, we can start from behind, from the back. So we would have a look there, where we're trying to find the largest item and moving that to the back. So we look through there, go 7, 7, 10, 5, and 4. Obviously 10 is the largest item, so we would move that to there. We'd swap that with the 7, and then the others stay the same. So it is actually possible with a selection sort to have 4, 5, 7, 7, 10. So selection sort is okay. That proves that option B is correct. But let's also have a look at the bubble sort, just to be complete. Now bubble sort. First element looks to its neighbour and changes if necessary. No change is necessary there. Now the second item looks to its partner, the 10, and looks to see if it needs to change. And no change is necessary there. So now we look at position 3. We look to its partner, which is 7. So they do need to swap. Okay, so we redraw that. We have 4, 5, 7, 10, 7. Now we're going to look at position 4. We've already looked at the first 3 positions. And we look to its neighbour, which is a 7. And again, they do need to swap, giving us 4, 5, 7, 7, 10. Again, that gets us to our answer after one pass, and we're sure that B is the correct answer.